You're live.
All right. Hi, everyone. My name is Reece Iriye. I am here to present my talk, Cloud versus Control, saving or syncing a product by managing your own application infrastructure. Just a quick little background on me before I get into anything. Currently, I'm a 5G core application DevOps engineer at Verizon. And in the past, I've also done internships at a company called Dialexa that was bought up by IBM in the Dallas area. And I worked at a financial firm, NextPoint, as well. If for any of you guys walking in here right now, I do have the QR code up for my LinkedIn, but that'll be up towards the end of the presentation as well. But a quick disclaimer before I start. Everything presented in this presentation is entirely my own opinion and not an employer's opinion. And on top of that, all products that I reference aren't necessarily an advertisement to the product itself. By no means an advertisement, endorsement, or sponsorship. It's solely just something that I chose to use for this presentation inside the demo. But let's kick this off. You're in a Zoom call with a couple engineers. It's 9 a.m. Tuesday. Camera's off. It's the early MVP stage of a product, and you're coming up with the whole idea of like, how are we going to deploy this? How are we going to deploy this app? What are we doing here? Everyone's drinking their coffee. People are stressed. People are drawing their little system design diagrams, thinking that they have the best design in the world. And they're like, I got this idea. This is going to work better. This is the way that we're going to do this. Some of these ideas, you're going to probably turn around and change in the future anyways. But there's some of these that are not necessarily irreversible, but can cause you months or even years worth of damage if done wrong. In this meeting, like you're just aware of how important this is. You're in this meeting and someone unmutes and goes, let's use Kubernetes. Let's bring in AWS, let's do EKS, let's scale fast. This application that we are deploying requires it, it's gonna need it, and we need to be able to fundamentally choose this as our option to go in this route. Someone else goes, I hate Kubernetes. Kubernetes is awful. This is going to be the most overhead. This is going to be a major problem for how we're actually deploying our application. I do like the idea of sticking on cloud and sticking with AWS. However, let's do an easier container management system. Let's do something like Docker Compose, so we could just set up a Docker Compose file, get that set up, deployed, done, works on every machine ever. Now, the third person. These are the people I love. This person's seen some crazy things over the past like 20 years in their career. They have completely, they've been working on OpenStack for a pretty long time. They're just like, absolutely like, what is this cloud native nonsense? We're not doing this crap. What kind of garbage is this? I've been deploying OpenStack for over a decade. On-prem is cheaper in the long run, and at least I control my own infrastructure, my own data. Why rent someone else's computer forever? Let's just buy the racks, call it a day. And yeah, this other person keeps saying like, hey, like I really think we should have a fully managed infrastructure solution. However, there's kind of a major problem here. In this talk, a lot of people kind of went in and immediately started talking about their tech stacks, what they'd prefer for infrastructure, whether we should go cloud, whether we should go on-prem, whether we should use Kubernetes, whether we should use Docker. Other opinions are likely probably floated around as well because there's so many possible ways that you can do this kind of thing. However, no one really talked about the user here. No one talked about how every decision that we make about deploying our application and setting this up, it's completely user impacting, and we need to really dive in, get a full profile of who the user is and who's going to be using this application so that we know that we can set up our infrastructure in a way that it won't fail. We're not going to have a major problem. We're not going to have a major problem where we totally fail to scale. Problems are happening, and we failed because we were thinking more about our tech stack and our infrastructure stack rather than the user itself. Now, I've come up with some like big umbrella overarching questions that I think are extremely important to discuss and talk about, because realistically, if you're not centering all your conversations about how you're going to deploy your application, how your application is going to be used surrounding the user, there's a big chance you're going to run into some problems in the future. Now, I think the number one question, the big umbrella question is, who is the intended application user? Who is the person that is, if you're hosting a web server or something, who is the person who is the person, or who are the people that are going in and actually accessing this page? Who is the target audience that we're specifically building this product for? Now, there's so many sub questions that you could go into on here, because asking who the intended user is really a loaded question that you can't answer in one simple sentence. You got to answer things like, are we building this for like an everyday customer? Are we building this for like a business? Is this an enterprise product? Or is this just an internal product for our own employees? What level of technical skill does the end user have? Is this a developer that we're building this for? Or is this a person who is like, I'm imagining, I love my grandparents, but tech, no. Like, we need to be able to design our applications in a way where like we know who the end user is. And if it's a person who is not familiar with tech at all, you need to make sure that the way that you're deploying your application represents that, showcases that, and really has that in mind the entire time. What problem is the end user solving with this app? That's a critical one as well. Do they need this application on some sort of special device, or will they be using something like their phone or their laptop, their everyday device, to access the application? Downtime is important as well. How will this impact this person if there's any downtime with the application? Will they require some sort of like support staff or anything like that to troubleshoot an error alongside them? Are users expected to have free access to this application, or is this a paid service? What kind of expectations on security and privacy are we expecting? Or do we have users in Europe that we need to really keep in mind GDPR? Are we dealing with like HIPAA data or anything like that? Like, these are the important things we need to ask as well. And are there levels of permissions that the user may have, like admin roles, ordinary user-based permissions, et cetera, et cetera? Now, where will the application users be located? Are they just going to be in Dallas, Texas? Are they commit your code all like, is it just people here using the application? Or is it people all across the world? Are these people accessing the application through some sort of firewall, or are they using their regular home Wi-Fi, or some like 4G, 5G on their phone, checking out a certain application? Are low latency connections required, such as like a trading application where every single nanosecond is like extremely important in the actual execution of your processes? I mentioned the GDPR thing before, but are people worldwide, or are they just in certain areas of the world? And I have a bunch of these. I'm not going to go through all these questions, but when will the users be using this product is an important one as well, because the exact timing, whether they're there from a 9 to 5 work, using the app there and then completely stopping during that, after that time, or if they're using it for a full like 24/7 service, that needs to be taken into account, because the way that you're incorporating CI/CD, whether you want automated deployments or if there's downtime and you're willing to take down your application to deploy a certain upgrade during a time that users aren't there, such as a time like a maintenance window, that's extremely important to consider as well. And lastly, for what purpose are these people actually using this app? There's so many purposes, and this doesn't seem like a full-on infrastructure question, but it's relevant nonetheless, because the reason why someone's using an app in the first place is absolutely relevant to the decisions that you're making and actually deploying an application. So back to this. Now that we have once really diving deep into a bunch of questions, talking about the who, what, when, where, whys of the user for an application, that's when you can really start diving deep into the infrastructure tech stack conversations. Like, getting back to that previous Zoom call that I was talking about, where a lot of people kind of threw their opinions about like a certain tech stack that is absolutely required. Maybe some part of it makes sense because maybe some of what they're bringing up is like a skill set that the team's already aligned with. But sometimes some of these problems do require a whole new level of a whole new level of planning, where you got to get your hands dirty with something that you haven't touched before. But I wanted to start and dive into the whole idea of cloud and the whole idea of on-prem from here, and basically dive into why would someone not want to use cloud. I know cloud is extremely popular. In most of my experience, actually, I've been working on-prem, so I have a little bit different experience from everybody. But on the cloud side, bill shock is 100% real from everyone that I've talked to, and it's like unbelievable. 50% of business, from a lot of the statistics that I collected from the internet, found that 50% of businesses in certain surveys had issues controlling their cloud costs. 44% attributed at least like a third of their costs to over provisioning of resources and unused resources entirely. I know you were talking about this a little bit in your presentation as well, but yeah. And then the average SaaS startup spends over $1.16 million annually on cloud services. So it's a big financial thing that a lot of people, when trying to deploy a product, anything like that, you really run into this problem. But there's a lot of pros to cloud adoption. And if I'm being honest, most people should probably go with cloud. The pros include, but definitely aren't limited to, speed and time to market, being able to deploy something fast, not having to buy a whole bunch of server racks and like setting everything up. Like you could spin up and you see like, if you want to do like an ECS instance or EKS for Kubernetes, like you can do that extremely fast. Scalability is absolutely something in mind. You don't run into this problem of, oh, I only bought this amount of resources to be able to host my application and now I need more. Well, you can go the route, if you're financially able to afford it on the cloud side, of saying, hey, let's bump up our resources more. We need it because we have more users than we expected, or maybe some flows through the application are taking up more like CPU or memory than expected. And there's so many other reasons that I've listed here as well. Ops, actual ops overhead is extremely low. Being an operations person, that's a major deal. Your global footprint of cloud services being everywhere. So especially the global user problem that we were talking about everywhere. If you have one instance just inside of, if you have if you have your own little machine in Dallas, Texas, and you have like a server rack there, but you're not hosting anywhere else, you're going to have issues with latency, which for some apps might not be a big deal. For most apps, it's going to be a pretty big deal if someone from Europe is trying to access it, for example. And you also have a built-in security win. Cloud services are extremely mature. They're extremely robust, and you're not good. And you lose the ability to make some mistakes that you could make on when going on-prem. But cons that happen as well. Unexpected hidden costs. Cloud providers love egress. Because they love charging you for egress. They love receiving data, but at the same time, if you send data out, they don't like that they don't get the data, so they just take your money instead. Over provisioning and resource waste are definitely problems that happen as well. You can have a bunch of volume sitting around that are taking up a bunch of cloud costs that you don't even realize, and then it could be too late at some point. But yeah, I'm going to skip a little bit of that just because we're in a little bit quick on time. But managing your own infrastructure in 2025, you might look at some of the problems that I talked about and been like, hey, we could save money. We could let's own our own data. Let's do it, guys. We're free from vendor lock-in. We're free from all these problems of unexpected costs. But the reality is, when you host your own application infrastructure, or when you're dealing with your own application infrastructure and not having another service manage a lot of it for you, you're entirely responsible for that too. I know, crazy phenomenon, but that steps in. But there are things that you can consider. When you do on-prem, a lot of the upfront costs are high because you need to actually get your before you're able to essentially release your application to the public in what I'd say is quote unquote prepared state. And the long-term cost control of for example, if your application is 99% egress, which can't really think of an exact reason right now, but if that's the case, that would definitely be extremely helpful there. You'll have pretty consistent performance across the board. You won't have the noisy neighbor problem that tends to happen. If you really need custom hardware for a specific solution that you're going for, you can use that as well. You have access to your own data. I mentioned that earlier. You're not locked. You can choose to be partial and slightly lock in on vendors on like some certain services that you have. But if you go the full way, there's no complete vendor lock-in, and you do get some of the pros out of that. There's some con to there as well, because with vendor lock-in comes in things being managed as well. But yeah, but there's cons to this as well. You can get your unexpected costs. They can hike up extremely. Oh wait, yeah, you get a whole issue when it comes to cons. Your cons mainly being not necessarily unexpected hidden costs. That was actually a bullet point from my other slide. That was an exit. I meant more on the side of you over provisioning and resource waste. That's a clear problem that you can hit if you have an insane amount of server racks that are deployed across the entire world, and you get a lot less users than you expected. You run into a problem that you just hit right there. You have a lot of issues getting out of this problem as a result. There's also a lot of ops overhead, because there's full new skill sets that you have to really train on for your team. And a lot of these include extremely good networking knowledge. That is an absolute must. Your knowledge of BGP and everything like that needs to be extremely high. There's the hardware and data center operations as well. You need to know your stuff when it comes to like VLAN switches, basically everything in mind. Storage and backup, none of that is completely, or at least partially, managed for you. And it's a lot harder to be able to do that on your own. And there's also the cost and energy management of dealing with a lot of your application. You have to really dive into the math of capacity and demand and think, okay, rolling back to the users and rolling back to everything on what we're expecting. How do we expect everything to scale up from what we have at the moment? But I wanted to dive into a case study really dive into this study that we had earlier of this Zoom call of people debating what should we do for our actual application, and do a quick user profile for someone who wants to look at a portfolio application, something simple as that. We're really not, we can take that out and then we can add some complexity a little bit deeper and deeper. But I really wanted to start out with this and just show this off. Audience, I'd say, if I'm making my own portfolio app, I think it'd be cool for you all to look at it. So I'd say you all are my target audience. Also, people interested in learning about more of what I do just in general. A lot of that's probably likely going to be in Dallas, but it could be across the United States as well, or maybe even outside. But a major portion of the traffic would be in this region. And some colleagues that I work with in my day-to-day may be curious about some of the things I've worked with in the past as well. So keeping it open for there. Tech skill sets and everything. I could see people with a wide range of a tech skill set looking at my app. So having something that's kind of approachable to both would be great there. And diving deep into someone's probably using something like a desktop, or maybe someone's on their someone decides to use their phone, take a look at my website. Short downtime is totally acceptable. I'm not too worried about that. It might ruin my reputation with one person if they're looking at my website and they're like, oh, this thing doesn't even load, this guy. Ugh. But no, it's fine. And security wise, I'm not doing any cookie collection or anything, just basic HTTPS, no crazy session management or anything like that. Diving deep into that, latency, not super critical. In the United States, I talked about that earlier as well. And when users are using this product, I really don't expect major spikes at all to be happening. Maybe at some point, if I threw my website somewhere else and was maybe threw it in a LinkedIn post or something, it's hey, this is my website, I'd probably expect a spike within the week or two of posting it. But this downtime on the app isn't going to cost me. It's not going to be a major problem. So thinking about the user side here, I'm not extremely worried about the user's perception of me if we were going to have a problem there. So doing all that and opening Grafana dashboards up as well, just for a monitoring solution to be able to track, is my application up? Is everything working? So hosting my own observability and Prometheus metrics to be able to do that. So something as simple as sending someone sending a request and receiving a response, getting some sort of HTML, CSS, and any sort of like static assets as well. But based on the conversation of like what I was thinking with like a user profile and how we go with this, I decided, hey, like let me just do like a quick like Go HTMX containerized application, super lightweight, something I like, something I've experienced with. Decided to do that. Why not? An SMTP server for receiving emails and doing things like Docker Compose, so that I can have basic container orchestration. I don't need anything crazy like Kubernetes for something like this. An Nginx reverse proxy, because I would like API rate limiting and certain caching capabilities there to be provided on that side, not necessarily on the application itself, while it can also happen on the application as well. Cloudflare DNS and GitHub Actions for CI/CD. Infrastructure-wise, deciding to use like a Google Cloud Platform virtual machine because it's super simple, costs like $15, $20 a month for me to actually host, keep up, have a static IP that points to it. Let me deploy all this, put this together, and since I'm managing everything, it's not too big of a problem. Now, diving deep into the actual like system design of how we did it, sending a request, like my actual application would receive a response, and it would be like, oh, here's the actual like rendered HTML, CSS, and everything as a result. And also publicly sourcing Grafana dashboards, because from my perspective, since I'm working more in like the DevOps space, the operations, I would like people to kind of know that I have skill sets in there for observability as well. But it's a super simple application that really doesn't have much complexity to it at all. If we were to really like, there's a single VM is totally fine, because I don't expect any like people going to this application and traffic scaling up to a crazy level. And as a whole, I wouldn't expect many problems happening from there as well. However, what if I change the MVP up a little bit? Let's say it's a critical product for users and ends up being a major, I end up like having some sort of e-commerce potential inside the application or wanting that. And let's say something like I own model weights for a certain AI model, and I decide I wanted to host that into an application. I don't know why I'd want to do that fully, but let's say this is the combination of things we wanted to do, and let's see how a user profile would change based on that. Your audience would be full-on consumers buying products, people interacting with AI models, the AI models as well. Maybe they need to buy some sort of API key that they can then use as a result and query my server from there. Casual, it would likely be a lot more like technical users that are using something like this, given the products that I'd be selling. And this, based on the whole user profile of everything that we're looking at here, one thing that we can conclude is that potentially Docker Compose and a single VM may no longer become sufficient. We might have to scale up and change how we're approaching this. Now, on cloud and Kubernetes could definitely be an option here, because there's major pros to that we could do. On cloud, you'd be able to have a fully managed control plane that wouldn't need to touch it at all. Worker node scaling, you'd be able to have that be totally fine. You wouldn't have to worry about full on-prem situation of under provisioning. Regions and availability zones are completely built in, so you'd be able to stick with that and not have the major DNS problem across. And you'd have the high infrastructure availability as well. But as a result, you'd also have the major costs that EKS implements on you as a result. However, if you were to go the on-prem route, say, you'd be able to predict your long-term costs a lot more and have a lot of ownership over the data that's being sent in. But in the meantime, you're gonna have some problems as well. You're gonna have the extreme high upfront costs. Like realistically, why would someone want to do this? Maybe there's some reasons depending on a certain application. Wouldn't be the worst idea in the world, but based on everything, yeah. You have the danger of under provisioning, over provisioning, as I was stating, and it's extremely difficult to scale if you have much more traffic happening in the application. But getting to the concluding remarks, a lot of the cloud pros come from your deployment speed, your elasticity, and being able to bring more instances of your application as you want. And the cloud provider ecosystem is extremely big for you to be able to add on to and do everything with. But you have the problem of the high risks of recurring cloud provider costs. But on the flip side, on the on-prem side, you got some pros such as data ownership. You're able to control your environment much more, and you have predictable long-term costs. However, you have the cons, which is the burden on a lot of the operations team and upfront costs, and you also risk the reliable uptime that a lot of these cloud providers have, and not being able to actually have that on your side, which can be extremely hard. So decisions surrounding your infrastructure, they're super important. They're essentially determining, they have a huge role in determining the actual success of your product in the long run. And decisions made years prior can punish you extremely, like, to so much in the long term.